Section 1.3, powers, square roots, and order of operations. Exponents. The exponent or power or index of a number tells us how many times the number is going to be multiplied by itself. For example, we have 5 to the power of n. This tells us that we want to multiply 5 by itself n times. So if n is 25, we're going to be multiplying 5 by itself 25 times. If n is 3, we're multiplying 5 by itself 3 times. 5 times 5, 25 times 5, 125. 5 is our base, and n is our exponent. We use the calculator in order to find those large numbers, especially when we're dealing with large powers, as well as our roots. So we have the power symbol, would be this inverted one on this calculator. Some calculators would have either x to the power of y or y to the power of x. So either your calculator have x to the power of y, y to the power of x, or the one that's on this calculator. So to find a number, or to find the power of a number, we have, for example, 9 to the power of 7. You would first click your power, the number 9, click first the number. In this case, you're going to click 9. Next, you're going to click the insert button, the power button, that is this one. Again, depending on your calculator, you might have this symbol, or this symbol. Once you've clicked that, you then click the exponent 7. In this case, it's 7. And finally, you click the equal sign. Next, we have the square root. Before I look at the square root, let's look at the square. Notice my first example was 9 to the power of 7. But if we had 9 squared, we would just simply click 9 and then this button, x to the power of 2. So we have click number, in this case, 9 again. And then we click our x squared button. And finally, the equal button, or depending on the calculator, enter. Now let's look at the square root. The radical symbol, the square root. This is the radical symbol, but we take for granted that it is the square root. We do not have a power here. So if there's no power, it means that it is actually the power. Sorry, it's no number. So it means that it is 2, which is the square root. So if we're finding the square root of a number, we simply click on this button. And then insert our number and click on the number that we want to take the square root. So if we want to take the square root of 9, we click on this button first, and then we click the 9 and our equal sign. Some calculators would not need you to click the equal sign, but if you need to, just click on the equal or enter sign. Next, we have the radical symbol. We're taking any root. Whenever we're taking any root, we're going to use this symbol on our calculator, which is in the background of our power button. So here, symbol is right here. So to get to it, we need to first click on the number itself, whatever value we want. So if we're taking the 9th root, we would first insert 9, click 9, then the shift button, then the power button in this case. So those of us who have x to the power of y, you would click that button instead of 9. And then whatever the numbers underneath this, let's take for instance, it is 925. I'm not sure. And then we would then click 925. So we would go number, shift, power button, and then the number that we want to take the root of. We also, like the square of a number and the square root, we also have the cube of a number and the cube root on some calculators. So if you're finding 9 cubes, you would just simply press 9 and the cubed button. If you're taking the cube root of a number like 729, you would then go shift, you would first press shift, the x cubed button, and then you would get the number 729. Because this symbol in the background will then come up on your screen, and then you would enter your 729 and your equal sign. So you can practice using your calculators to find the power of a number is any power, or any root taken of any of our numbers. Continuing. Write in exponential form. In exponential form means that we must have it so that it looks like this, 5 to the power of n. This is our exponential form. So let's look at some examples. We have 12 times 12 times 12 times 12 times 12. So we know we're multiplying 12 by itself. 1, 2, 3, 4, 5. So that's 12 to the 5th power. We have negative 2/3 times negative 2/3 times negative 2/3. Now we need to make sure that our negative 2/3 remains in brackets or parentheses. So we have our negative 2/3, and we're multiplying it by itself 3 times. X times 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 X. Let's count how many times. 1, 2, 3, 4, 5, 6, 7, 8. So we're multiplying X by itself 8 times. 3y. 1, 2, 3, 4. So we have 3y to the power of 4. Evaluate the following. When we're asked to evaluate something, it's asking us to find the actual answer. So here now is where we will be using our calculators to find our values. So A, we have 4 cubed. So we would simply press 4 and the x cubed button, or the x to the power of 3 button. For those of us who do not have the x cubed button, we would just go 4, shift 3, and that gives us 64. We have negative 2 raised to the 7th power. This one, we need to make sure that we open our brackets. First, we would click on open brackets, our negative symbol. Now, we want the negative symbol, not the subtraction symbol. Your negative symbol will be found on your calculator. It's either given to you like this on your calculator, or this on your calculator. If it's in the background, we're going to press shift first and then the symbol. But for most calculators, it's a button. So you just press that button first. After you open your bracket, press the negative button, then the 2, close your bracket, press the close bracket button, your power button, and then your 7. After that, press your equal or your enter. That gives you negative 128. So again, it was open bracket, negative 2, close bracket, power button, 7, equal. Next, we have negative 3/4 raised to the power of 4. Now here we have to open our bracket first, press the negative button. For some of us, we have our fraction symbol. We can try using that. Most of us would have A, B, C, A, and then B over C button. Some of us would have a button looking like this. Whichever one you have, if you have the A, B, C button, you would press now your 3, this button, and then your 4, and then you would close your bracket. For those of us who have this one, you would now you would press the button itself first. To the top, you would enter your 3, and then to the bottom, you would enter your 4. You would use your arrow key, the arrow button, to get down, to go down, pressing the down arrow button for this one to get to this position right here. Again, for those of you with this one, you do not have that much work. You just press the 3, this button, and then the 4, and then you can close your bracket. But for this one, you press the 3, the down arrow button, and then you want to go back to press the arrow button going towards the right, and then you close your bracket. After you've done that, once your bracket is closed, you now want to press your power button and insert your number. This would give you your value as a fraction. It's now positive 81 over 256. Notice that my answer is still a fraction. It's given to me as a fraction, so I'm returning it as a fraction. My fraction cannot be reduced, therefore I leave it as is. Other than the fact that it's going to be reduced to 3 over 4, and we don't want to reduce it since we want to raise it to the power of 4. So we leave it as is. Next, we have 2.5 raised to the power of 6. Open bracket, 2.5, close bracket, power button, 6. This gives us 244.140,625. Some calculators would turn it to a fraction. And in this case, our fraction would give us 15,625 over 64. Once you get that fraction, you're going to look for this symbol. Let's put it right here. S D. Press that symbol and it will take it to a decimal. We'll return it to a decimal. Next, we have 2x to the power of 5. Now, the 2 and the x is in parentheses. This is the same thing as 2 to the power of 5 and x to the power of 5. Notice we cannot do anything with the x to the power of 5, but we can deal with the 2 to the power of 5. So you would press 2, power symbol, 5, and that gives you 32x to the power of 5. Next, we have negative x over 3 raised to the power of 4. Let's deal with our sign first. This is the same thing. We have negative to the power of 4. It's positive, so whenever we have an even power and we have a negative, we're multiplying a negative and the power is even, our answer is going to always be positive. If our power is negative, if our power is odd, our answer will always be negative. So again, if we have an even power, our answer will always be positive. If we have an odd power, our answer will always be negative. Let's look at B and C. B, negative 2 to the power of 7. 7 is an odd number. My answer is negative. C, my power is positive. Therefore, my answer is also, my power is even, my power is even, therefore my answer is positive. Odd power, negative answer. Even power, positive answer. So we have negative x over 3 raised to the power of 4, an even power. Our answer is going to be positive. So we now have x to the power of 4, because this 4 applies to both the numerator as well as the denominator. And our 3 is to the power of 4. So we now have x to the power of 4. And we go back to our calculators. 3, power symbol, 4, and that gives us 81. Square roots. Now, in dealing with the square root, we're looking at this symbol, the radical symbol, without any number placed there. So the square root of a number, a, is a number x such that x squared is equal to a. So the square root of a number, we're looking for a number when multiplied by itself, actually. So the square root of 4. So we're looking for a number when multiplied by itself would give us 4. And that number would be 2. So let's look. So we have the square root of a. Again, this is our radical symbol, the square root symbol. And we have our number, the base number itself, which is known as the radicand. Now, the square root of a number normally gives us 2 values, a positive value and a negative value. However, we use the positive value, that is the absolute value, when we're looking for the square root, unless we're solving an equation, a quadratic equation of some sort. But even then, we still use the positive value if we're dealing with distance. So our principal square root will always be the positive one, that is the non-negative square root. So that's the one we're going to be using. So again, square root of a number can either be positive or negative. And we know that because negative times a negative will give us positive, just like a positive times a positive will give us a positive. So the square root of 169 is the same thing as negative 13 times negative 13. So the square root of 169 is negative 13. However, 13 times 13 is also 169. So the square root of 169 is positive 13. But again, we're going to be using the principal square root, that is the positive one. Evaluate. Now, for this one, some of these we know without even having to go to the calculator. But first, we would then put in, if we need to go to the calculator, we would click on our radical symbol. For the square root case, we just click on the radical symbol without any x attached to it. And then we would press and insert our number. So the square root of 121, this one we know, would be positive 11. Again, we're only using the positive one. Square root of 256, positive 16. Again, we're just using just the radical symbol. Insert the radical symbol and whatever numbers underneath the radical symbol. Here now we have negative square root of 0.0625. This negative does not apply to the radical, what's underneath the radical. So we put the negative sign first, and then we deal with the radical symbol, and we insert our 0.0625, and that gives us 0.25. So we have negative 0.25. Next, we have the square root of negative 1.44. Now, the square root, anything that comes underneath the square root must be 0 or a positive number. It cannot be negative. So whenever you have something looking like this, you just simply put not real, because it's not a real number. It's not a real number. But let's check and see what our calculator would say. So you would insert your square root symbol just like before, your negative sign, and then the number 1.44. And your calculator should give you my error. Now, for those of us who have a fancy calculator, it would give us something like 6/5 or 1.2 in the letter I, telling us that it's a complex number. So even so, it's the same thing as not real, because the number is not a real number. Next example, we have negative the square root of 16/25. Again, we can use our fractional symbol. We know that's going to be negative. Using our fractional symbol, we first insert the square root symbol. Whatever's fractional symbol, you have the ABC. You have the ABC. We press now 16 after the radical symbol, 16 ABC 25, and then enter. Or if you have the fraction symbol itself, you would then insert your you would click on that, then 16, use your arrow button to go down, click on the 25, and then just simply press equal. And that will give you 4/5. It'll leave it as a fraction, negative 4/5. But for those of us with the ABC, it would give you 4/5, which is the same thing as 4/5. Just wanted to look at this again. We have our negative sign. We can separate these two because it's a radical symbol. We can now do it like this. Or you can do it the way we did it, I said before. Or you can separate it. And then you can find the square root of 16. And then the square root of 25. I just want to put my negative sign in the center. It doesn't matter, but preferably the center works, because the negative applies to any one of these. If the negative now is, if I put it on the top, negative 4/25, my fraction is still negative. It does not matter again, like I said. Now we have the square root of 9y squared. This one I would definitely need to separate, like I did here. I'm able to separate a fraction, and I'm able to separate a product, because our fraction represents a quotient, and our product represents multiplication. Here, when they're combined together, it represents a product. So I can now separate them as the square root of 9 and the square root of y squared. The square root of 9 we know is 3. Now I have 2. Square says I'm grouping in 2's. Once I'm grouping in 2's, I can then take my base. Both of these are 2's, so my answer must be y. Because y times y gives us y squared, therefore the square root of y squared must be y. Here, we want the square root of x to the power of 8. Now, x to the power of 8 is, and we want to group in 2's, so we have the square root of 2. It really shouldn't be 2. It should be x to the power of 2. This is the same thing as x to the power of 2 times x to the power of 2. That's 4. That's 4, so 5 times x to the power of 2 times x to the power of 2. So I've grouped them in 2's, and I can now separate it. I will have 2, because I still know that it's x. I'm going to get 1, an x coming from this one coming from this one coming from this one, and 1 coming from this one. And let's just separate it so we can see it a little bit clearer. We have x to the power of 2 times x to the power of 2 times square root, that is, of x to the power of 2 times the square root of x to the power of 2. The square root of x squared gives us x, and we have 4 of them. So our answer is x to the power of 4. So again, I'm taking x to the power of 8, and I want to group it to see how many groups of 2's I can get from 8. I know that I can get 4 of them, so let me just redo this as a different way. We've seen that one. So let's take this equation and change it. So we have x, the square root of x to the power of 8. But I know there are 2 times 4 gives me 8. So I have 4 groups of 2's. And this is the same thing as x squared raised to the power of 4. And I know that the square root of x squared is x. And my answer must be raised to the power of 4. Now we have the square root of 3 over 75. Now I don't know the square root of 3. I don't know the square root of 75. But look, I am able to do some working here. 3 can go into 3 once. 3 can go into 3. 75. 25 times. I do know the square root of 1. And I do know the square root of 25. The square root of 1 is 1. The square root of 25 is 5. And I'm rewriting 25. The square root of 25 is 5. Now, for those of us who are using our calculators, when we put in our square root in a fraction symbol, and we put our 1 over, our 3 over our 75, we are going to get, let's do 3, 75, we get 0.2. Most of our calculators will take us immediately to 0.2, and some of our calculators will take us to the fraction, give us back our fraction. So either way, you get back the same solution. It's the same thing. 1 over 5 is 0.2. So you can use your calculator, or you can notice that 3 and 75 have 3 in common. So you can divide both numerator and denominator by the same number, and then take the square root of the separate value. Now we have the order of operations. Applying the order of operations when brackets, exponents, and roots are involved, we need to follow this. First, we combine numbers inside the parentheses, inside our grouping symbols. Then we raise numbers to their indicated powers and take any indicated root. We then multiply and divide from left to right. And then we do our addition and subtraction again from left to right. So if brackets are involved, we deal with them first. Powers are involved, we deal with them next. Multiplication is there, multiplication and division, we deal with them according to the way it's presented to us from left to right. Addition and subtraction is involved, we go left to right as well. Let's look at an example. Evaluate 6 minus 4 in bracket. We have a bunch of brackets here. And then we have a big bracket, 2 minus 4, and the negative 8. So let's deal with our brackets first. 6 minus 4 tells us we must deal with this bracket. 6 minus 4 is going to give us 2. Dealing with our big bracket, we're going to keep it. We have inside the big bracket, we have another bracket, so we want to deal with that. 2 subtract 4 is going to give us negative 2. And that is multiplied by negative 8. Multiplication tells us that we can multiply left to right. So we have negative 2, because all of this now tells us that we want to multiply. Let's see with the bracket first. 2, bracket means multiply. Negative 2 times negative 8 is going to give us a positive 16. 2 times 16 is going to give us 32. So again, brackets first. So we deal with both brackets. We can deal with them both at the same time because they are not interfering with each other. So we deal with this first, and then we just move on and we deal with this. Next example. 4 plus, open bracket, 4 squared minus 13 raised to the power of 4, subtracting 3. So we have brackets and exponents involved. So we're going to deal with the brackets first. Bringing down 4, positive sign, open bracket. But inside my open bracket, I have a power, so I need to deal with that. 16 minus 13, close bracket, power of 4, subtracting 3. Bringing down my 4, my plus sign, dealing with my bracket. 16 subtracting 13 gives me 3. And 3 is raised to the power of 4, subtracting 3. I have 3 to the power of 4, so I need to deal with that. So I still bring down my 4, plus 3 to the power of 4, which is 81, subtracting 3. Now I can go left to right because I just have addition and subtraction. 4 plus 81 is 85. 85 subtracting 3 is 82. I know we might be tempted to put everything in the calculator at once, but it's order of operations, so you need to perform it show all of your steps. Next example. Here we have 8 subtracting -6, open bracket, 2 multiplied by -3, subtracting 5 multiplied by 2 raised to the power of 2, divided by -2, 2 raised to the power of 3. The negative is in raised to the power of 3, just the 2. And then we have 6, negative sign, 8 over 2, close bracket. So let's work this one. Bringing down the 8. Now, we're able to deal with our negative sign, but let's leave this alone for now. We have negative, open bracket, -6, close bracket. Now let's deal with the inner bracket. Dealing with our numerator, we have negative times 2 times -3, giving us -6. We have our negative sign, 5. 2 raised to the power of 2 is 4, so that's 5 times 4. Denominator, we have our negative sign, 2 raised to the power of 3, which is 8, times 6, subtracting 8 divided by 2, which is 4. This is equal to 8, subtracting -6. We have -6 in the numerator, -5 times 4, giving us -20, divided by -8 times 6, giving us -48, subtracting 4. This is equal to 8, subtraction sign, -6 times -6 plus -20. Signs are the same, so we're going to just add, giving us -26 divided by, signs are the same in the denominator as well, -48 plus -4, giving us -52. I'm going to move over, bringing down my 8, negative sign, -6, dealing with my bracket. Let's make this a multiplication sign one time, since we just have the one bracket. Because my sign is about to change, I can remove the bracket, but if you want to keep the bracket, that's fine. We have negative, so we're going to cancel each other out. 26 can go into 26 once. 26 can go into 52 2 times. So we have 1 over 2. Now, we can cancel. 2 can go into 2 once. 2 can go into -6, -3 times. Or, for some of us, we would have preferred 8, negative, and -6. We would have our -6 times 1 over 2. Some of us would have to multiply. So we would have had 8, negative sign, and then we have -6 times 1, giving us -6 over 2. And this then gives us 8, subtracting 2 divided into -6 is going to give us -3. We have 8 negative times a -3 gives us a +3, and this gives us +11. Same thing, we would have gotten the same result here. When I cancel, 2 can go into 2 once, 2 can go into -6, -3. We would have ended up with 8, subtracting -3. We have 8, negative times a negative is giving us a positive. So we end up with +11. either way, we get the same solution. I could have changed this immediately to positive 6 and move on. I just opted not to. But again, you could have opted to change the sign here. Negative times negative 6, giving us a positive 6. And proceed. So let me continue. We have 6 open brackets. Sorry, 6 negative 7 open bracket. Negative 2 squared minus 2 times 3 squared minus 6 divided by square root of 9 close bracket. Bringing down my 6, my negative 7, because I cannot touch this 7 until I've dealt with everything inside the big parentheses. Now I have negative. This negative does not apply to the 2 squared, to the square that is just the 2. So 2 squared is 4. So that's negative 4. Subtraction sign. Dealing with my bracket and sign. I have 2 times 9. 3 squared is 9. Subtracting 6 divided by the square root of 9, which is 3. Close bracket, close bracket. Bringing down my 6 minus 7. We have negative 4, my negative sign, dealing with my inner bracket. 2 times 9 is 18. Subtracting 6 divided by 3. 6 divided by 3 is 2. Close bracket. Bringing down my 6, my negative 7 minus 7. I have my negative 4. I'm dealing with my bracket. 18 subtracting 2 is going to give me 16. Close bracket. Bring down my 6 minus 7. Signs are the same, so I'm going to just add and keep the sign. I'm going to now have my bracket or multiplication sign, whichever one you choose. Signs are the same. 4 plus 16 is 20. So that's negative 20. We now have our 6. So we have 6 we bring down. Negative 7 times negative 20 gives us a positive. Negative times negative is a positive. So that's negative, positive 140. Negative 7 times negative 20, positive 140. And we have 6 plus 140 giving us positive 146. Evaluate. We have the square root of negative 5 all squared plus 2 plus 3 squared over the absolute value of 24 divided by 2 times 6 minus 5. So we have the square root symbol. Negative 5 squared. It deals with the negative, so it's negative 5 times negative 5, giving us positive 25 plus 2 plus 3 squared. 3 squared is 3 times 3, which is 9, divided by the absolute value, 24 divided by 2, giving us 12 times 6. Because we have division and multiplication, we must go left to right, subtracting 5. Dealing with our numerator first. Because we only have positive signs, we can just go ahead and add all 3 of them together. 25 plus 2 plus 9. 25 plus 2 is 27. 27 plus 9 is 36. We now have the absolute value of 12 times 6, and 12 times 6 is 72. Subtract 5. The square root of 36 is 6. 72 subtract 5 is equal to 67. So we have the absolute value of positive 67. This is equal to 6 over the absolute value of 67 is 67. We have the absolute value, so we have the absolute value of 6 minus 3 squared, which is 9. Open bracket, 4 cubed. 4 cubed is 64. Divided by 2 to the 5th power, which is 32. Subtracting the square root of 36, which is 6. Each one of them is separate, so I'm able to do all of them one time. Next, we have the absolute value of 6 minus 9. Signs are different, so we're going to subtract. 9 taken away 6 is 3. And we take the sign of the biggest absolute number, that's 9, and it's negative. So our answer is negative. 9 subtract 6 is 3, so that's negative 3. Multiplied by 64 divided by 32, which is 2. Subtract 6. The absolute value of negative 3 is positive 3. Remember, it's a distance on the number line, and distance is always positive. The distance from 0 to number line, so that's 3. So 2 subtracting 6 is equal to negative 4. We subtract and take the sign of the biggest absolute number. So that's negative 4. 3 times negative 4 is negative 12.